Hello everyone. So we're about to see how we can import core data into a log, okay, using GeolOil software. So usually people deliver core data in spreadsheet files, like this example, okay? So we have here, okay, we have measurements of core permeability in the lab, core permeability, core porosity, matrix density, and many other curves, many other properties. Okay, so we have to save the spreadsheet file in a format called CSV, that is comma separated values. And we have to put the, the first cell has to be MD, measured depths, the labels, okay? And you put the next column, one property, the next column, a property, and so forth. Okay, so the first column has to be measured depths. To put MD for the title, and then the values of measured depths. Okay, that's it. We have here even some spectral and gamma ray measurements, potassium, thorium, uranium. They are located towards the end. Okay. Very good. Okay. So you have to save that as comma separated values. Okay, comma separated values. This is the one. Okay. Okay, then you go, then you may minimize your spreadsheet file. Okay, now go to your log and okay, go to curves. But before I go to curves, let's have a quick look at the log. So this is a classic reservoir. This is a classic reservoir. So we have clays. So we run a mineral solver. We detected what are the type of clay. So we have quartz, we have silt, we have halite. The clays are halite, smectite, and kaolinite and chlorite. The four most common types of clays: quartz and silt, which are not clays, of course. Okay, very good. Okay, good. Now we have a pore space track. We have density, porosity, and neutron porosity, and permeabilities. Okay, neutron porosity, this is interesting. So we have this light red curve here, this one is neutron porosity. This one, neutron porosity. Okay, so we have neutron porosity, we have in this green color, we have total density porosity, and later on we already corrected that to have effective neutron porosity and effective density porosity, and the final porosity is that the average between the effective neutron and the effective density porosity, and you see how these three blue, red, and black curves match very well. Okay, where we have clays and cells like this one, we have a difference between neutron porosity and density porosity, total neutron porosity and total density porosity. So this difference, this feeling is related to shale, to clay. If we go to the very end, you see that, okay, in this region we have very low gamma ray, a signal of around 16 or 15 GAPIS units. And that's why you see there is a less difference between neutron porosity and density porosity. Okay, very completely different from this case, for instance. Okay, very well. Here we have the track of permeability. Interesting. So we computed here not only the absolute permeability, but we compute also the, the effective permeabilities to oil, KO, and the effective permeability to water. So in GeolOil, you can express that in several ways. So one of the nicest ways to express that is using transparencies. So we have here the collection of trees. So we have here the total porosity, sorry, the absolute permeability in black. We have the permeability to oil, the effective permeability to oil in green, and the effective permeability to water in blue. So using transparency, you can see everything there. You can see the curves. Okay, very good. Okay, so remember the spreadsheet? We have saved that. So we have to import now that core information. Okay, very good. Okay, so again, now we go to curves, and we have several options to import core data, to import curves and export curves. So this collection of three are the functionality for Excel, comma separated values. You can import core data in comma separated values and import curves in comma separated values. The difference in between core and curves is that in principle curves are continuous. And core data can have jumps and gaps and data and whatever. We can also export. Okay. So this is a large log. It has so far 152 curves. Okay. Okay, let's import core data as comma separated values. You have to remember where you put that. Things in videos. Core data. Perfect. Okay. This is the one. It takes a while. Okay, it has to be comma separated value CSV import. Okay, it takes around, I don't know, maybe 1 minute or so. Everything's large, but it works. Just wait a little bit. Okay, it's done. Okay, so the imported core data was put at the end of the collection of curves. That's it. So we should have a look on those. How can we do that? Okay, go to edit table. Okay, you can highlight the curves you would like to see. So again, we're going to see the imported core data. You hit table, and you have that. That's it. That's it. Okay. For most of the depths, of course, there's no data. They are blank or minus 999.25. Okay, you move down. Okay, here appears the data. Okay, the core sample, the core porosity, permeabilities, oil saturation, water saturation, and matrix density. Okay, here we have some data for for spectral gamma ray, but they don't appear. But if you go to the end, the very end, here they are. Okay, here they are. Like in the Excel file, they put the spectral gamma ray data to the end, so the deepest depths. Okay. Okay, look at the gaps between the data. No, these are some gaps. Of course, you'll put minus 999.25 in between. That's it. Okay, now a nice feature is you can make an auto contrast with the colors if you want to see major trends. So when you click here, you see how all the saturation colors increases dramatically, and you can compare one column with another, like this one, something like that, total API, thorium, whatever. So this is very handy. So it's very easy to see what are the stream values, the largest values, the smallest values. It has a very nice color contrast, auto contrast. Okay, very good. So we have that. Now let me deselect this. Deselect. Okay. Maybe select all. Maybe select or okay. Okay, so let's make a plot of the imported curves. Okay, so we have, let's take a note. So we have here core porosity is my pencil. Core porosity is 154. And we have core permeability 155. 155. Okay, very good. 154 and 155. Okay, good. So you go to display, step 1, tracks and fields on pore space. Okay, you go to the very end. We have to add the core 154 close to the very end. So where's it? 154. And now permeability is 155. We have to put that into the permeability track. This one. Permeability 155. This one, okay. Well, we are not about to touch the stratigraphy. Curves. Okay, we have here. Okay, you remember 154 and 155, they are there. Okay, so we should use the same scale for the other porosity. So you see the porosity including the neutron ranges from 0 to 0.6. So let's put here 0 and the right click 0.6. Okay, good. Now the stroke has to be points. I want core points. I do not want a solid curve or something like that. The thickness, I don't know. Let's start with thick. See what happens. Core permeability. Oh, let's change the color for core porosity. Maybe magenta, something like that. Okay. Core permeability. Let's put that perhaps in red. This is red. Okay, so starting from 1 and beyond. So core points are maybe thick and see how it looks. Okay, yes they are, perfect. So these are, you see this magenta, these points are the core porosity. They match very well with the computed core effective porosity. Well, in some cases, but that is normal. That is a good match. We may change the color for porosity, maybe to deep blue, something like perhaps this one, deep blue. Okay, very good. And the porosity, well, is there. Those are the red points, red dots. Of course, you see that those red points has a better match with absolute permeability instead of permeability to oil and permeability to water. This one, it touches or tries to touch the black curve here. Okay, not too bad. So we have a reasonable permeability model equation. Not too bad. Okay, very good. Now you may ask, how can I shift core data? Okay, how can I shift core data? So to do that, perhaps it would be a nice idea to open a, okay, let's look here, open that same file again. Or shift directly the core data. Okay, let's for instance this region, this is from around 17, okay, around 1800. We're about to shift, let's say, the permeability, okay, the whole collection. Let's around the collection of core point measurements around 1800. We're about to shift all the core information. So we go to curves. So let's suppose, okay, let's shift deeper. So I want to shift from here, maybe 10 feet downwards. Okay, you see the delta measure there, from here to there, 10 feet. Okay, so we have to go to curve, highlight the curves, deselect, highlight all the core data from here to there, go to edit table, go to the depths, I think it's 1800 dimension. Okay, so this is, let's see, 1800. Okay, it starts, okay, it starts on 1793. Okay, 1793. Okay, this is core porosity. Okay, starting from here. Okay, core porosity, core permeability. Okay, so we want to shift starting from there, and the end depth. Okay, the end depth is around these values, 1814, essentially that, 1814. Okay, edit table from here to 1814, so okay, 1814. Okay, good. Okay, we can unselect this one, approximately that one. Okay, so we want to shift that core information. Okay, so we need to shift downwards. Okay, so we shift here. So anytime you shift, you have one depth step. So one depth step here is 0.25. So if we are about to shift 10 feet, we have to click 40 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. Okay, 40 clicks. That's it. So you can shift upwards and shift downwards. Very simple. Okay, now go to display and that should be ready. Let's see. Perfect. You remember what's centered? Well, now it's shifted. Now it's shifted. So we shifted at the same time porosity and permeability. You have to shift all of them at the same time. Okay, this is all for now. Thank you very much for attending. Please remember to share this video in your blogs or Facebook or whatever, or LinkedIn, and also please subscribe to our YouTube channel. Have a very nice day. Thank you very much.